So I want you to take a second and just kind of look around the room you are in right now.
Just take a look.
Yeah, literally just look around. You can probably see the paint color on the walls, maybe, the texture of the floors or that furniture you spent weeks picking out. Every visible inch of that space.
Right.
But you are entirely blind to what is arguably the most important part of the building. Running directly behind that drywall is this vast, invisible nervous system, the electrical wiring.
It's true. I mean, we spend so much time curating our visible spaces,
Oh.
right? But we completely ignore the infrastructure that actually makes those spaces habitable.
Yeah.
We naturally maintain things we can see. Like if your roof is visibly sagging, you fix it. If your HVAC unit is sputtering and grinding out in the backyard, you call someone.
And you hear it, so you deal with it.
Exactly. But because electrical decay is hidden behind plaster and insulation, it's almost entirely out of mind for the average person until the walls literally start smoking.
Which is terrifying. And today we are diving into a comprehensive stack of maintenance data, diagnostic guides, and field reports from AT Electric LLC. And it proves that this invisible nervous system is actually trying to talk to you. You just, don't know the language yet.
It definitely has a language.
For sure. And AT Electric, they're a family-owned electrical service company based out of Mansfield, Texas, specifically at 7920 Rodeo Trail, serving the broader Dallas-Fort Worth area. And what I really love about diving into their source material is how it takes these highly intimidating, invisible physics and translates them into everyday reality.
Yeah, they make it very accessible.
So our mission today is to explore what those flickering lights in your hallway actually mean, why a tripping circuit breaker is actually your best friend, and why trying to upgrade a ceiling fan on a weekend might be significantly more dangerous than you think.
Oh, the ceiling fans. We will definitely get to that. But, the timeline of that hidden decay is what really stands out first in their field data. The sources point out something critical about aging infrastructure in residential areas. Homes built before the late 1990s, for example, were simply not designed for the massive power loads we pull today.
Not at all.
Back then, developers were installing like 60 amp or maybe 100 amp electrical panels.
Which, makes total sense for the era, right? Like in 1995, you had a box television, a refrigerator, a few lamps, maybe a desktop computer if you were lucky. The power draw was relatively tiny.
Exactly.
But I was looking at the actual numbers for today's households in the notes, and it's wild. We have multi-zone HVAC systems running around the clock. We have electric vehicle chargers in the garage pulling massive continuous wattage.
And air fryers, induction stoves.
Yes, a dozen smart devices constantly sipping power. The sources say modern homes frequently require a minimum of 200 amp service or even higher just to function safely.
Right, and so when you try to pull a 2026 electrical load through a 1995 panel, you create a severe structural bottleneck.
A huge bottleneck.
Because the electrical panel is the vital core of the property. It takes the raw, massive power flowing from the utility grid, and it has to divide it into safe, manageable streams for your kitchen, your bedrooms, your garage.
Okay, let's unpack this with a visual because I think that helps. I like to think of the electrical panel as a highly stressed out traffic cop standing in the middle of a massive multi-lane intersection.
I like that analogy.
Yeah. So its job is to take all this incoming utility traffic and route it without causing a massive pileup inside your walls. But here's a common assumption I hear all the time, and I really want your take on this.
Sure.
If my circuit breaker keeps tripping and shutting the power off in my living room, isn't that a sign that the breaker itself is just faulty or annoying and needs to be bypassed so I can just keep watching TV?
Wow. Okay, that assumption is exactly how house fires start.
Wait, really?
Yeah.
Just from flipping it back on?
Yes. A tripping breaker is a vital, intentional defense mechanism. If we use your traffic cop analogy, a tripping breaker isn't a broken traffic light. It is the traffic cop intentionally throwing up concrete barricades because the bridge ahead is on fire.
Oh, wow.
It is cutting the power to prevent a catastrophe. The sources identify 4 primary reasons a breaker trips, and none of them should ever be ignored. Overloaded circuits, short circuits, ground faults, and arc faults.
Okay, I want to break those down because people hear those terms and they just sound like generic electrician jargon.
Yeah.
Let's stick with the traffic cop. An overloaded circuit is pretty straightforward, right?
Very straightforward, yes.
You just have way too many cars trying to cram onto a single one-lane road. Like you plugged your space heater, your gaming PC, and your vacuum into the same room, and the wires literally cannot handle the traffic without melting.
Correct. The breaker senses the wires overheating from the friction, the electrical resistance of too much current, and shuts it down.
Makes sense.
But a short circuit, on the other hand, is much more violent.
Violent. How?
That is when a hot wire comes into direct, unintended contact with a neutral wire. In your analogy, that's a car driving the wrong way down an off-ramp.
Oh, a head-on collision.
Exactly. It creates a massive instantaneous collision of electrical current that totally bypasses the normal route, and it generates an intense surge of heat.
And a ground fault, how is that different?
Well, a ground fault is when that current finds an unintended shortcut to the earth. Usually electricity flows in a controlled loop, but if water gets into an outlet, or maybe the insulation phrase, the electricity might decide that the fastest way to the ground is through the metal chassis of your washing machine.
Or I'm guessing through you if you touch it.
Exactly, through you. So the breaker detects that power is leaking out of the loop and kills the circuit instantly.
Okay, so the one that really caught my eye in the AT Electric materials, though, was the arc fault. That just sounds like something out of a sci-fi movie.
It does, but it is arguably the most insidious hazard because you can't see it happening. An arc fault occurs when you have a loose connection or damaged wiring behind the drywall. Electricity actually jumps or arcs through the air between the compromised wires.
Through the air?
Yes. It is essentially a tiny, continuous lightning strike happening inside your wall.
That is terrifying.
It really is. That arcing generates localized temperatures of several thousand degrees, which, as you can imagine, easily ignites the surrounding wood studs and the paper on the drywall.
So if you just keep marching down to the basement and flipping that breaker back on without investigating the root cause, you are forcing that traffic cop to let cars drive straight into a burning bridge.
You are demanding that the system ignore its own safety sensors. And there are physical red flags on the panel box itself that indicate you've pushed the system too far.
Like what? What should people look for?
Well, the sources urge property owners to visually inspect the metal box housing their breakers.
Right.
If you see rust or corrosion, moisture is getting into the electrical system.
Which is never good.
Never. If you see scorch marks, you've already had miniature fires.
Yeah.
And most critically, if the panel feels warm to the touch, or if you detect a faint, fishy burning odor, you are dealing with a severe immediate fire hazard.
A fishy odor.
Yeah, that smell means plastic wire insulation is actively melting inside that box.
Wow. Which brings us to a really fascinating dynamic. Because the melting insulation and the arcing wires are hiding behind the walls, the house has to find a way to communicate that failing system to you through physical symptoms in your living spaces.
Yes, the house is trying to warn you.
The vocabulary it uses often comes in the form of flickering lights or strange smells. But the sources are careful to point out that not all symptoms carry the same weight. You have to learn how to decode these warning signs.
You do. Not all flickers mean your house is going to burn down.
Right. The notes break this down perfectly because I feel like people tend to either ignore all flickers or panic over all of them.
Very true.
Like if you have a single LED bulb in your kitchen that's flickering rapidly, it often just means you have an incompatible dimmer switch.
And the mechanics behind that are really interesting. Older dimmer switches were basically just resistors. They dimmed the old incandescent bulbs by turning the excess electrical energy into heat.
Okay.
But a modern LED bulb doesn't work like a hot wire in a vacuum. It has a micro driver inside it. A tiny computer.
Oh, interesting.
So if you feed an LED a chopped up electrical wave from an old rheostat dimmer, that internal computer driver starts turning on and off dozens of times a second, trying to interpret the voltage.
And that's the flicker.
That's the localized, harmless flicker you see.
It's annoying, but it's not going to burn the house down. But the sources highlight a completely different symptom that is a major red flag.
Yes, the dimming.
Yeah, if your lights dim specifically when a large appliance like the air conditioner, compressor, or the refrigerator starts up, that is a completely different message.
Completely different. That indicates a severe capacity bottleneck at the panel. Large motors require a massive spike in power called inrush current just to start spinning.
Just to get going.
Right. So if your lights dim when the AC kicks on, the system is struggling to provide enough juice for that initial surge. It is literally stealing voltage from the rest of the house to feed the compressor.
So to put that in everyday tech terms, a single flickering LED is like a minor typo in a Word document.
Good analogy.
It's annoying, it's a localized glitch, but it doesn't break the system. But widespread dimming, when the AC kicks on, that is like your whole computer freezing up and lagging because you tried to open a massive video editing software while running 10 other heavy programs at the exact same time.
Yes.
The processor, or in this case, the electrical panel, is totally overwhelmed.
And just like a freezing computer, It's not just an annoyance. It actively damages the hardware over time.
Yeah.
Every time those lights dim, your HVAC compressor is experiencing a split-second brownout.
Which can't be good for it.
It's terrible for it. It's struggling for voltage, which causes the motor to run hotter and slowly destroys the internal components of an appliance that costs thousands of dollars to replace.
Man, I was reading the section in the sources about how this specific bottleneck affects commercial real estate and business owners in the Dallas-Fort Worth area, and the stakes are so much higher for them.
Oh, absolutely. They face a compounded version of that exact problem. Commercial infrastructure degrades differently than residential wiring because it handles massive continuous loads, often utilizing complex three-phase power.
Right.
The sources highlight how businesses track these power failure frequencies in their maintenance logs. They're constantly facing this repair versus replace math problem.
It's the sunk cost fallacy in action. When you have an aging retail shop or office building, the instinct is to just keep calling someone out for quick, cheap repairs just to keep the lights on.
But those continuous repairs on an aging system rapidly compound. You are paying endless labor and diagnostic fees to essentially put a Band-Aid on a failing nervous system.
A Band-Aid on a bullet wound, really.
Pretty much. And more importantly, you're risking operational downtime. If the power drops or a breaker trips during peak hours, you can't process transactions, your security systems go offline, and your employees are idled. You bleed money by the minute.
Yeah, a full system replacement feels incredibly expensive up front. But the sources argue it offers compliance with the National Electrical Code, manufacturer warranties, and protection against those revenue-draining outages.
Upgrading commercial infrastructure dramatically reduces safety liabilities.
Yeah.
It lowers long-term utility bills because modern systems route power far more efficiently without the resistance buildup of decaying wires.
Okay, so that same compounding failure we see in commercial buildings from ignoring the root problem, that is exactly what homeowners accidentally trigger when they try to upgrade their own fixtures to save a few bucks.
Yes, the DIY disasters.
This happens all the time during remodels. A homeowner finally notices the warning signs. Or maybe they just want to put a nice new chandelier in the dining room, and they try the DIY route. And this is exactly where the actual physical structure of the house fights back.
The source material from AT Electric gives a very stark warning about upgrading ceiling fixtures. People assume electrical work is just color matching.
Just connect the black wire to the black wire.
Exactly, black to black, white to white, but they completely ignore the physical load on the structure.
Right. They note that a heavy chandelier something weighing 50 pounds or more, or a motorized ceiling fan, absolutely cannot be attached to a standard junction box.
No, it cannot. A standard junction box is literally just a plastic cup nailed to one side of a single wooden ceiling stud.
Just plastic and a couple nails.
That's it. It is engineered and rated solely to support a lightweight, static light fixture, like a glass dome and a couple of light bulbs. It handles maybe 5 or 10 pounds of dead weight.
Right.
The physics change entirely when you introduce massive weight and kinetic movement.
Okay, here's where it gets really interesting, though. Let me play devil's advocate for the weekend while you're listening to this, who just bought a ceiling fan at the hardware store.
Right, let's hear it.
If I'm just swapping out a basic ceiling light for a new fan, the wires are already there. As for the weight, I have a drill. Can't I just use some thicker, longer screws to hold the fan bracket into that standard plastic box? What is the actual mechanical danger?
The danger is centrifugal force and dynamic torque.
Okay.
You aren't just hanging a heavy painting, you are installing an engine. As the fan motor spins those blades, it generates constant vibration and significant rotational torque. It is actively twisting and grinding against the ceiling mount every single second it operates.
So it's literally trying to tear itself out of the ceiling.
Exactly. If you drive thicker screws into a standard plastic box that's only nailed to one side of a stud, that continuous movement will inevitably strip the plastic threads or pull the nails right out of the wood. Over time, that vibration stresses the wiring connections inside the box, creating the exact arc fault risk we discussed earlier.
The tiny lightning strikes.
Yes. And eventually, the structural integrity fails entirely, and the spinning fan unit violently pulls free and crashes to the floor. To do it right, professionals have to install a fan-rated box.
So how is that different mechanically? A fan-rated box.
A fan-rated box incorporates a heavy-duty steel brace that actually ratchets outward, spanning the gap between two separate ceiling joists.
Oh, so it connects to two pieces of wood, not just one.
Right. It bites into the structural skeleton of the house on both sides, distributing that rotational torque across the framework rather than hanging it all on a single plastic cup.
That is a terrifying visual if you've been sleeping under a DIY fan
I
installation.
know, it makes you want to go check your ceilings.
It really does. And beyond the physical danger of a fan falling on your bed, I read a detail in the sources regarding insurance that blew my mind. They explicitly state that DIY electrical work can completely void a homeowner's insurance policy if a fire or major damage occurs.
It's a huge risk. Insurance companies employ forensic fire investigators.
Right.
If your house burns down and they trace the origin of the fire back to an arc fault inside a non-compliant, unpermitted junction box you wired yourself on a Sunday afternoon, they can determine you violated the terms of your policy.
And your coverage can just be denied.
Absolutely denied. Hiring licensed professionals isn't just about avoiding a heavy lifting job. It guarantees National Electrical Code compliance and provides an absolute legal shield for your property investment.
So if we are putting down the wire strippers and relying on professionals to avoid disaster and keep our insurance intact, I want to know what we should actually be asking them to do. Like if I bring an electrician into my home or my business, how do I future-proof the property?
Well, the sources outline several strategic upgrades that offer massive long-term value. The first is integrating advanced technology like dedicated electric vehicle chargers.
That makes sense.
Yeah, as society shifts away from combustion engines, having a properly rated, safely installed 240-volt EV circuit in the garage is quickly becoming a baseline expectation for real estate value.
And given that AT Electric operates out of North Texas, they deal with intense weather. So I imagine surge protection is a massive priority.
Whole home surge protection is critical, especially against severe Texas storms and unexpected power surges from an aging utility grid.
How does that actually protect the house, though? Does it just act like a reinforced dam blocking the power?
It acts more like a high-speed pressure relief valve.
Okay.
When lightning strikes the grid or a transformer blows down the street, an enormous spike of high-voltage electricity rushes towards your panel. A whole home surge protector instantly detects that overpressure and shunts the massive spike away from your breakers, dumping it directly into the earth ground outside your house before it can ever reach your internal wiring.
Oh, wow. So it never even gets inside.
Exactly. It prevents your expensive HVAC systems, your smart appliances, and your computers from being fried in a microsecond.
I also noticed a fascinating detail in the source materials regarding daily efficiency. They mention a company called El Monte Tree, specifically in the context of guiding clients through LED lighting upgrades. It wasn't just about buying brighter bulbs, it was about the strategy of the layout.
Transitioning a property to LED lighting is a massive strategic advantage, but it requires balancing the aesthetic vision with the technical load requirements.
What do you mean by that?
Well, a company coordinating these upgrades looks at how the lighting drivers reduce the overall strain on the electrical panel while simultaneously ensuring the light temperature and placement enhance the room's function.
Right, because nobody wants ugly lighting.
Exactly. It's about lowering the utility bill without making your living room feel like a sterile hospital ward.
That makes perfect sense. Lowering the load on that traffic cop while making the intersection look better. So to keep all of this infrastructure healthy, AT Electric LLC, and again, their number is 682-582-500 if you're in the DFW area, they emphasize the absolute necessity of routine electrical inspections.
They do.
And they mention this is vital for everyone. Older historic homes, downtown retail shops, brand new subdivisions, and property managers.
The vulnerabilities are vastly different depending on the property type, which is why the inspections are universal. Historic homes have decaying, crumbling cloth insulation.
Sure.
But new subdivisions are just as vulnerable. They often suffer from rushed construction where wires might be improperly stapled or pinched behind new drywall.
I wouldn't have even thought of that.
Oh yeah, it happens a lot. Property managers, meanwhile, need inspections to catch tenant-caused overloads before they turn into multi-unit emergencies.
But are these inspections actually required by law? Like, if I buy a house or lease a commercial space, is the city going to force me to do this?
Well, while municipal laws vary, and routine inspections aren't always legally mandated on a fixed schedule for private homes, they are universally recommended during key transition periods.
Like when?
You should absolutely demand an inspection during a property sale, before installing large commercial machinery, or during any major home remodel.
Because if you're remodeling a kitchen, you're usually adding power demands. A double oven, a bigger fridge, more recessed lighting.
You are drastically increasing the load. You need absolute assurance that the existing panel can handle the new demand before the contractors put up the new drywall. Once those walls are sealed and painted, you are back to being totally blind to the nervous system.
Which brings all of this together perfectly. If we look at the major takeaways from this deep dive into the hidden physics of your home. First, respect your circuit breakers. If that traffic cop is throwing up barricades, don't just push past them.
Right. Investigate the overload, the short, or the arc fault.
Second, learn the language of your flickering lights. A single bulb is a local glitch, but widespread dimming when the AC kicks on is a system freeze that is actively destroying your appliances and requires a panel upgrade.
And third, respect the physics of torque and vibration. Leave the heavy motorized ceiling fixtures to professionals who use steel-braced, fan-rated boxes. Do not risk your safety or void your homeowner's insurance by trying to outscrew centrifugal force.
You cannot out-DIY gravity. I want to leave you with a final, lingering question to ponder on your own today. We've talked extensively about the massive demands of modern households and businesses. As our society pushes rapidly toward fully electrified lives, from the electric cars sitting in our garages, to the induction stoves, to the AI-driven smart appliances running in our kitchens, will the massive surge in residential power demand eventually outpace the local utility grids themselves? As we rush toward a sleek, technological future, could the invisible, aging wires hidden inside your own walls become the ultimate bottleneck to progress? It's something to think about the next time you look at the paint and the floors. And remember the invisible nervous system running directly behind the drywall.